I have been standing in front of people speaking since before some of you were born, and my pulse still gets up to 115. So, it never gets easier. They just think it is. I'm talking to you today about the basis of this project is something that I worked on for the last year or so. We'll talk about Bluetooth. I did a lot of work with some Bluetooth sensors. We'll see kind of what's going on with Bluetooth, what Apple gives us, and then a lot of the Bluetooth is really mucking around with stuff that's not well documented. This talk is for a couple people. I'm assuming that some of you might have Bluetooth projects you're working on. You'd like to see how well you're doing or how poorly I'm doing or vice versa, get some ideas. Some of you might be considering some Bluetooth projects, or you fiddled around with it, you've given up, you'd like to see where it is now. And then this being Colorado, some of you might have visited a dispensary for breakfast and you're just really happy to be in that chair. And you're going to be there. And welcome to all of you. I'm really happy you're here. My talk today starts in New Jersey. This is a company I've been working with for a while. If you think about New Jersey is a state. If you're not from our country, it's a province sort of thing. The Duke of York owned this massive piece of land, cut it in half, New York, New Jersey. And if you're from America, you probably think of this, traffic, because one of the heavily trafficked roads in America is the Jersey Turnpike. That's the west side of New Jersey. Or you might think of the Jersey Shore, the beaches, the east side of New Jersey. But really, most of New Jersey, and especially the southern part of New Jersey, is farmland. And then unlike the central part of the United States, which has a lot of wheat and soybeans and corn, specialty crops is what's grown in New Jersey. And specialty crops are things like cucumbers, squash, strawberries, peaches, specialty crops. Don't know why they get to be specialty crops, but they are. And in New Jersey, the most famous of the specialty crops is blueberries. In fact, they will call themselves the blueberry capital of the world. And the blueberries, Hamilton, New Jersey is the central part of that, so about halfway between Atlantic City and Philadelphia. They're in the southern part of New Jersey. It's all blueberry bushes. And so if you're working for a company that does blueberries, what you find is that you get up really early. I live in Washington, D.C., and I was regularly commuting up there. It's about a 3-hour drive. I can do it almost with my eyes closed. And it starts really early because it's hot. June and July is when they're picking, and it's migrant workers doing the picking. They come from, start down in Florida, and then they work their way all the way up to Maine and Canada, and then kind of come home for the winter, and then do it again in the spring. And one of the reasons is because of the way the bushes look. So blueberries grow on a bush. You try to pick the bush 3 or 4 times in the season. If you'll notice here, some of these blueberries are ripe, but the green ones are not. And they're not going to ripen at the same time. So it is manual picking. There's no machine picking yet. They're sort of working towards it, I think. They're trying to grow bushes that will grow in a different way and only have berries on the top so that they can then design some machines to come along and do that picking. That may happen in my lifetime or it may not. But so now it's migrant workers. And designing apps for migrant workers is actually quite interesting. A lot of them don't speak English. Many of them don't read. So handing them an iPhone and asking them to perform some tasks has some challenges. We're not going to talk about that today, but if you want to talk about that some other time, I'm here all week. I'm the guy in the tie. This is what we did, and so this is all the work I did with them. We're going to really focus on the Bluetooth stuff, but we started with using some iPhones out in the field, reading barcodes, so we can track the blueberries as they get picked. The workers tend to get paid by how many they can pick, which is sort of fascinating to watch how fast they can move them down a row. Then we take the crates, put them in the packing house where they're cleaned and sorted, put into those containers that you've seen them in the grocery store, the plastic ones, the little green ones. That's all done pretty early on. We had some iPhone stuff there that was doing the weighing so we could check for yields. And then after that, they're in these giant refrigerated containers until they're sold. You can drive a forklift into these things. They're really big. They're as large as this room, and we had Bluetooth, humidity, and temperature sensors in there to keep track of everything that was going on. And then we did some more barcodes and photographs as we shipped them out, and then Bluetooth sensors again in the trucks. And so these are the kinds of apps I've been writing with these nice people. So that's why I believe that I am capable of speaking to you for about an hour about Bluetooth, and hopefully you now believe that what I say is probably true. Bluetooth is a standard, and almost all the Bluetooth chips that you'll see, regardless of the vendor of the sensor, will be either made by Nordic Semiconductor or by TI. And TI and Nordic really drive the standard. There's Bluetooth.org, which is the standards body, and they do the sorts of same things you might think of any standards body. There's SIGs, and there's different groups that come up with this or come up with that, and they write papers, and they read each other's papers, I'm sure. There's two kinds of Bluetooth. So the one we'll talk about just now, and then I'll stop talking about it unless I make a mistake, is classic Bluetooth. So that's what you really think of as your mouse pairs to your computer. There's this formal process. They pair, and if you want them to unpair, there's a formal process. Unpair. It's very much like marriage. There's the marriage, there's the divorce. Whereas Bluetooth Low Energy came along a little later, much more transient, kind of like a singles bar. They meet up, they do some stuff, they can break apart. They meet up, they do some stuff, they break apart. That's really the big difference. Classic Bluetooth uses a lot more power because it's really thinking about, there's a desktop machine, you're in your office or you're on the go, you can deal with AAA batteries, AA batteries, a lot more power in there. Bluetooth Low Energy wants to deal with a coin cell. And it wants that coin cell, the little thing you might put in a watch, to last about a year or two. So much lower power draw with Bluetooth Low Energy. And that's the big difference. And Bluetooth Low Energy, especially with iBeacons, is where we in the iPhone space first started to learn about this technology. When Apple came up with this iBeacon thing, gave us some frameworks to work with, and Bluetooth Low Energy was taking off about that time, and that's where it's going. All right. So the way that Bluetooth Low Energy likes to think about the world is this thing called a GATT database. And I'll be honest with you, I don't know what GATT means. I'm pretty sure G is probably global, right? That sounds good. The other letters mean something, I'm sure. But the GATT database is maintained by the Bluetooth organization. And what they say is, okay, for all these sensors, heart rate monitors, pulse sensors, watches, all these things, we've got categorized all the things that you could do. And then for each of the things you could do, we've got categorized all the values, and we assign them specific numbers. So this is really the key of the GATT database, is you've got a specific number. So if I've got an environmental sensor, I might have a specific number set up for that. We could see this. I was worried about lighting. It looks like play to me, but I'm up here. And so you could see that when we started this project, we knew we wanted temperature and humidity, and then we also wanted the battery state. How much battery is left in my sensor? And so we dutifully went to Bluetooth.org, we found the correct ones, we found the correct values, and we set that all up so that when my phone is running, what I can do is I can say, I only want to see sensors that are going to offer this service. Don't show me your headphones. I want to only see things that are giving me temperature and humidity. And we were building Arduino sensors, and that's probably a whole nother talk, because that was a huge failure, but this is sort of what we did. So get your characteristics. A service has a bunch of characteristics. Characteristics are really going to equate to a value. So the actual Celsius temperature, the actual humidity that I'm getting is going to be a characteristic. That's all encompassed in a service. Same thing with battery. And so we had reverse DNS doodads. We had some numbers, and that's how we can set up our sensor that's sitting on the wall, that's communicating. And then any app can look for that sensor based on those numbers. So let's see. Bluetooth pretty much all around us. Some devices go both. This is going to be fun. This will be our first, possibly last demo, depending on how well I pull this off. That just looks horrible. Okay, but we're going to do it anyway. This is one of the tools that Apple provides to us for looking at Bluetooth devices, and so we'll go ahead and turn it on while I start talking. There's a lot of us here in the room, and so this is actually even more than I had imagined in my wildest dreams. So we're up at 157. What's happening is my computer, which has a Bluetooth radio, and all of your computers and your iPods and your headphones and your Apple Watches, you're all broadcasting. And somewhere in here are my little environmental sensors that I've set up here and that my friends back there have. And so what we want to look at, let's see if I can figure this out. Here we go. Is everybody's here on the right. So we've all got a device ID. Some of us might have device names. My little sensors all have names. Here they are. So here's one of my little sensors. This WGXI beacon is that little thing right there that's measuring the temperature. And notice it's at 65, 75 is the signal strength. Anything at about 65, 75 is signal strength. I can still talk to it. As it starts to approach 100, or infinity, but it stops counting after 100, you can't really talk to it. And this is an interesting thing about Bluetooth Low Energy. These advertising packets, what they're called, will send us signal strength. And I know it's there, but until the signal strength gets to a certain level, I can't conduct a communication with it because I'm not going to get the back and forth that I need. So for instance, if we look at this beacon, which is right there, and I'll go ahead and connect to it, maybe. Sometimes I get to hit it twice. We'll see that, hopefully, there we go, it'll give us some information. Now, anytime that the app has been able to translate to actual words, that tells me that they're using the GATT database and they're using one of the known services and there are known characteristics in there. Anytime it's just some random stuff, they made it up. So then I've got to go to the vendor and figure out what that means. This will be a recurring theme. I'll hopefully not belabor it so much that you're tired of it, but that's a temperature and humidity sensor and an accelerometer. There are definitely entries in the GATT database for that. But, much like that designer you work with who refuses to follow the HIG, these vendors do not want to use the GATT database. They've got our own. So, that's one thing that you will learn, is you've got to do this for every vendor, and every vendor is going to be different. But I can see here, at least they use the battery service, and I can see that there's a battery level. Because it's translated, I know that it's using the standard GATT values, so I'll be able to read that. And it's actually 64. When you work with, this is hexadecimal, we work with this for a while, you realize that's a fully charged battery. Now the other interesting thing is I've got down here, somebody's got a tile. Yay, got a tile. So here's FAR 20. This is back there in the back of the room. This is about 10 meters from me, and it's broadcasting as loudly as it can, 4 decibels, which is 10 meters, which is basically from me back to about the second to last row. Now it's got a friend also in this back there who's not broadcasting at the highest level, and AL26, you can't see it at all because it's broadcasting at a lower level. So one of the things you can do is you can, now FAR 20, which is the one broadcasting there as loud as it can, that's going to be a huge hit on the battery. The battery's not going to last a year. It might last 6 months. But I've got a much longer range that I can talk to it. And we're in a nice open space. There's a lot of Bluetooth going on, but we're in an open space, so I'm getting almost the full 10 meters. If you think about some other things that will impact this, if you stick it into 18-wheeler, which happens to be a big metal box, all of a sudden that drops it. If you stick it into a large refrigerated container, that'll drop it. But what we found is that as long as I can get even a little bit of this advertising data, if the advertising data it gives to me has some valid information in it, I don't need to connect. So I can get away with, I can barely make out that it exists, rather than having to have a nice strong connection to go with it. Let's see, so then the next part of this is this one, which of course will, oh, this is hard to work with. Let's see if this will work. There we go. So we'll see again, this is kind of fun. So here's everybody's laptops, some of your MacBooks. Oh, look, somebody's MacBook. So even though you think, okay, a MacBook, that's classic Bluetooth. That's probably, but many devices will do both. Do classic Bluetooth for something. Apple uses for continuity, this nice thing that we love for continuity. That's Bluetooth Low Energy between all your devices, so they can talk to each other when you're on the plane and stuff. So let's connect to this person's MacBook. And there we go. And so we can connect to their MacBook. We can see some of the characteristics it's showing me. So I can read these things. Because for the most part, the Bluetooth Low Energy stuff you're going to read, it's okay. It's public information. The secret stuff is going to be protected somewhat. So we don't mind. It's not that creepy that I'm looking at whoever's MacBook this is. Wow, that's terrible font. Anyway, these are actual words, and those are words as well. Now, the other thing that, yes, this is an Apple conference, but there's a lot of things here that say Apple. And the reason there are a lot of things here that say Apple is because the first 4 digits of your advertising data is your manufacturer. And if you want to be an iBeacon, you have to say you're made by Apple if you're not. So lots of people, because they want to participate with iBeacons, that manufacturer always says Apple. So just because it always says Apple, and it's really fun to look at this, because you look at this, wow, everyone has a Mac, no one has anything else. No, it's because the beacon service happens to use Apple's manufacturer ID. Okay, this is good. Oh, I did it. All right. Oh, wow. Okay, I'm going to talk even faster. So core Bluetooth is what Apple gives us. It gives us, there's a couple of processes. We would discover the devices. That's what we did when I hit scan. We just sort of saw what was in their room, and we could read the advertising packets. Then we could, if we want to, we can connect to the device. Now we can get more information about that device. And then a nifty thing that you do is you can, once you know there's a characteristic there you care about, I can either write to it directly, I can read from it sometimes, right there, or I can just say, you know what, whenever your value changes, send me a text, or not text, alert me. And core Bluetooth and the device will manage that for you, you don't have to worry about it, and whenever that characteristic's value changes, you'll get an alert, you'll get the information, you don't have to do anything else. Unfortunately, I like to think it's because Apple thinks they've solved the problem, they're done with it. They don't really update the Bluetooth documentation much anymore, so you do need to read the header files if you're going to work with this. That's much more up-to-date documentation, but there's the links there. Just an aside, the way I like to give talks is I'm hoping that you're entertained, I'm hoping that you get some high-level things, and then there'll be a lot of stuff on the slides and in the speaker notes that are way more detailed. And that's really because what I want you to do is kind of take those, and in 6 months when they say, who's going to work on this Bluetooth project with those cool people over there? You can say, oh, I know Bluetooth. And you can pull the slides out then, and then you can learn it before you have to know it. So there's stuff in here, you'll see it. You catch me later, I'll talk to you about it, no problem. So we've got the CB Central, that's the class if you are going to consume. If you want to consume information, you can be a CB peripheral. That means you're going to give me information. You're going to use that GATT database. Macs and iPhones can be either or both. And as of iOS 10, we've got a new key. We've got to stick an info plist for privacy. And it's like the other privacy keys you might have run across. You know, as you're doing your development, it works fine. There's a little log message. And then as soon as you get to the store, it'll crash. That's awesome, but it's one of those. And then as of iOS 11, Apple is now actually giving us the ability to do the low-level CB to CAP if we want to directly talk to a device. If you're going to go that level, then hopefully you're building your own sensors. So if you're building the devices, the hardware, and you're doing the software, then you can avoid the whole GATT database and go directly to the stream and do the stream of data just like you would to any other system. Is this close? All right, this is close enough. So the setting it up is relatively straightforward. I've got the central manager. Unlike some of the other managers that you might use, like notification manager, I need to keep a reference to it. You don't just talk to it and stop. You have to keep a reference to it or it won't work. And that takes some getting used to. But that's the way it happens. And the reason it happens that way is because I might have 6 different managers in my app, right? I might be looking this manager talking with those devices, this manager does those things, and we want to keep them separate. So you have to keep a reference. And then this key I've got here, this is one of the key parts to making it talk to you in the background. Remember, Bluetooth Low Energy is all about conserving battery, conserve. And so if you don't explicitly say you want it, once your app goes to the background, you get nothing. You get no notifications. So I've got to explicitly ask for them, and I've got to ask for them with a queue that I provide. Different queue for each of my managers, right? Because I don't want my padlock manager to get alerted when my environmental sensors change. And then I can scan for peripherals. And you saw we had, did we get up to 200? Maybe 200 devices in this room. In this instance, I only wanted to see my sensors. So I'm saying scan only for those peripherals that say that they are providing this service. And that helps cut that down. So then I'll just get my devices rather than all of your lovely devices. The other thing I can do, because scanning for peripherals is a really battery intensive thing, once you've picked up the UUID of a peripheral, that's not going to change. And so you can then, the next time you want to talk to it, you can ask the manager, you say, do you still know about this peripheral? Is it still out there? And you say, oh yeah, I can still see it. Then you can say, now I want to connect. So what you want to remember is you want to scan initially, and then as soon as you sort of know them, then stop scanning. And the nice thing about the UUIDs is they don't change. So you can do something like check out all your sensors in your environment, write them all down, feed that data directly into your database, then you never scan, because then you're just always asking for those peripherals you know exist. Core Bluetooth was probably written right about that time that we were switching over to blocks. So there's no blocks in Core Bluetooth, it's delegate pattern. So if you love blocks, it's delegate pattern. If you love delegate pattern, it's delegate pattern. We've got two delegates we care about. We've got the manager delegate, which gives me all my callbacks. When I say start scanning, it's going to call back and say, I discovered this one, I discovered this one. And then I can say, okay, we'll connect to this one, I connected to this one, I connected to that one. That's the manager, and then it hands it over to the peripheral. Because now the peripheral, I'm talking to a specific sensor, not all the sensors. And that's when I can say, discover services, and the peripheral eventually will come back because it's all asynchronous. All of it's asynchronous. They'll say, I got some services for this peripheral, here they are. And you say, okay, I want that one. Talk to that characteristics. That will then come back as well. And if I ask it to write a value out, after that round trip is made, I wrote the value out, it received it, it wrote it, it'll let me know. Yes, I successfully wrote it, or no, I didn't, that sort of thing. And that's really it. Do it. All right. Where's mine? Okay. Right, Xcode. Boop. This just makes me so sad. Map delegate, which you can't see. So here we're going to now have some, I'm going to look for these sensors. So I've got these little sensors, I've got this little app. Now this is kind of like if you ever worked with camera before and you say, oh, I'll just use the stimulator, it's awesome. Yeah, it doesn't work. The Bluetooth radio on the stimulator, even though the Mac's got one, not going to work. So you got to do it on device. Do your testing on device. I'll just do this, now I can see. It looks great on this screen. All right, fire this up. And what we're going to do is you're going to be looking at the log, which hopefully you can read. So I started up. Now I've got three devices out here. I've got 028, which is right here. It'll find it really fast. It's already found it. And then I've got 020, which is back there. And then 026 is just really too far away. Can the two of you, can you look down and read the barcode on that device? Which one's 026? You are. Okay, can you sort of bring it, maybe give it to one of these nice people up here? Or maybe pass it forward so we can get close enough? There we go. Now that it's out from under his chair, notice. Oh, you can't see. That's right, you can't see. All right, hang on. It's close enough. Through the magic of the internet. Sure. Yeah, sure. Go ahead. Okay, so 026 now moved its way up. We can now see it. 020, which is still way far back there, we can see it. Okay, so now this is the part that's going to sound weird. It's not. So if those two of you who have those, notice right now they're 73, 74 degrees, and the humidity is 40. So the humidity in here is about 40. Go ahead and put them in your palm of your hand. Go like this and blow in there. Change the humidity for us so that we can see that the temperature and the humidity should start to change, and then hopefully, if my app works correctly, we should start to get some changes. Oh, seriously? I hate computers. I really hate them. All right. Any luck? No luck. That's okay. That was the part that I was pretty sure wasn't going to work because it would have been cool if it did. But this is all coming from the advertising data. And as the advertising data changes, it should start to change. And then if I connect, so we'll try to connect to this one, which is pretty far away, so it may or may not get there. What's been happening over the last 24 hours, so this is going to be harder. The RSSI was on the edge for that one. It may or may not be able to connect, even though it was able to read that advertising data. Looks like maybe that one's too far. I'm just going to connect to the one that's sitting here on the desk. Hopefully that one will work since nothing else is working right now. And then flip over here. And you can see that it's... there we go. All right, so then we can see that over the last 24 hours, that thing has been sitting there collecting data. And we can see that this was a different package. The only way I could see that historical data was that I had to connect to it, I had to give it a password, and then I had to ask for data from the last 24 hours. So I had to be close enough. So the only one I was able to successfully do was this one here that's sitting on the desk. Okay, so back to here, extend the desktop. And this again, this is just sort of what we saw. This was my super backup with nothing worked. We only had most nothing worked, just not every nothing. Okay. Now the one thing you would have seen, is that Bluetooth in the background is pretty tricky because we're trying to conserve energy. So I have to do a couple of things. I had to have that key in there that I wanted. I've got to name that queue. There's a special entitlement in Xcode. And then the other thing you have to do, which unfortunately it took me a long time to understand, was you have to express interest. So we were very happy at the Blueberry Farm because we saw that we could get all the data we needed from the advertising packet. We didn't have to connect. So for a while, our little sensor app, which is very similar to the one that you saw that was so beautiful, is it just discovered. And so it would discover, and it would get the data, and it would discover and get the data, and that was great. And we'd go to the background, nothing, ever. Nothing ever. And we couldn't figure that out because we didn't understand. And what we finally realized was we're conserving energy here. Just discovering it, that means nothing to the system. But once I said, okay, you know what? I really want to connect. Now it would remember it. And so we found this thing which hopefully continues to work. This was what we did. We discovered it. We would add it to our list. We thought we were good. But then it would go away. But we had to add this connection in the background to make it so that now the system says, oh, okay, you cared about that one. I'll keep an eye on it. So when the advertising packet changes, when something changes about it, I'll let you know. This is not the way you're supposed to do it. This is bad. Because just like the central manager needs to have a reference, you have to keep a reference to anything you connect to. And that sort of makes sense to you, right? Because you want to kind of think about it and maybe talk to it later. We were just doing this to make it keep reminding us. So this will probably break, like really crunch time sometime. It's giving me this little thing. You've seen this, something similar at least. Every time you write let something until you get to the next line. It says, hey, you know you're not using this variable. That's kind of this. You're not using this. Security. So security is Bluetooth security. So you saw that I was able to kind of creepily snoop around, and the temperature and humidity sensors that we had, they've actually got a passcode on them for some features but not others. And the way you do security with Bluetooth low energy, you can do it just like near field communications does, right? Near field communications, that security, you're at the store, the security there is that you got to be this close, right? So there's physical security. I can't be across the room and dealing with your near field communication. I got to be really close. That's security there. We can do that. We can lower the transmission power, and so you got to be really close to the sensor. And then the other way is these passwords. The password, just because everything has to be in the GAP database, is a characteristic, and so I connect to the device. Now, it has to still tell me about all the characteristics, but what most of the vendors seem to do is they'll give me nonsensical data until I give that passcode. Then they're happy to give me the real data. So the first thing I have to do is I have to discover the characteristics, find out which one is the password. These are just variables for the UUID, so you don't have to look at UUIDs. And then I send it some data. I send it some zeros, So a bunch of zeros, very secure, I know. And then I get it back, and I get back that it was successfully written. Actually, I wouldn't know here, right, because I'm not handling the error, but it's a demo, nothing works. And once I know the token is set, now I can fetch all the data. Now I know there was a password, and then for the duration of this connection, the sensor will let me talk to it. Okay. That's really all there is as far as the code. The code you write is going to be maybe a few more lines than the code I wrote as far as the life cycle of talking to those sensors. And as you might notice, the session is not actually done, so there must be more. And there is. Intermission. All right. The rest of the time you're dealing with Bluetooth, you're going to be spent dealing with the vendor's implementation of the Bluetooth, and you're going to spend time dealing with packing and unpacking bits. Because we're trying to compact everything. And a good way to compact everything is to go ahead and take the binary representation of the number I want, and then maybe convert it to hexadecimal, and then squish them all together as much as I can with no space in between. So you might think, okay, a comma delimited list. No, commas take up space, no commas, right? You just have to know that the first 2 bytes means this, the next 9 bytes means that, the next 13 bytes means this. And those of you who know anything about binary and bytes and bits are starting to realize that no, you should do 2s, 4s, 8s, 16s, not 3, 7, 12, 20. Well, they're compacting, so we have to deal with that. It's not going to be a clean break. You might see a hexadecimal number, 4C, comes back. Well, that's actually 3 different things, and you've got to slice it up. So that's what we'll talk about now. Second half. Here's some things I've got. When I give the slides into the Slack at the end, all of this code is actually in Playgrounds. You can download it. If you like that sort of stuff, you can fiddle with it. You can play with slicing of these numbers. But there's a couple of techniques that we're going to use. Oh, I have a laser pointer. No, it doesn't. Okay. So if you're a Swift person, you've probably only ever dealt with data because you've got an API, right? You get the data comes down, I give it to the JSON parser, I get it, take JSON back, and I'm done with it. Now it's something I can look at. And you've never really thought about data. And data is basically an array of bytes. Unsigned integer 8s. It's an array. Now, I can represent this array all sorts of ways. If it's 0x blah, 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 that's a hexadecimal byte. If it's 0b blah, 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 that's a binary byte. If it's just a number, that's a number. That's a decimal byte. And I can mix them and match them. It's just an array of 8-bit integers. I'm going to say bit and byte the wrong way, and those of you who know that I'm wrong, just sort of think less of me, and those of you who don't know that I'm wrong, just make sure you check your work. But we can see that all of these, even though I made them different ways, are identical. I'm just using a different numbering system. The computer is converting it all to binary anyway. Because it's an array of binary bytes, well look, I could just use a for loop here, right? And then I can print out each one of these. This is kind of cool. We'll run across this a couple of times. Yes, I'm shaking because I'm nervous. You could turn it into a string, because if you just try to print it out or log it or something you want to look at it, it's always going to give you the binary representation. Not helpful here. But what you can do is string constructor has 2 optional parameters. One of them is the radix. Is that the way you say it? Anybody know? I've never said it, only read it. Don't know how it's pronounced. We're going to call it radix then. So I'm saying that I'm giving you a string, it represents a number, it happens to be base 16. And I can deal with that, which is all right. Here's a number, and I'm going to print it out as if it was base 16. It'll do the conversion. Or base 8, or base whatever you want. And if you leave it alone, it's base 10. That's why if you do string with a number, it'll print out that number for you. Because it's an array, now, so here's what we have to do is a lot of times we have to take these long bytes, and we have to say, okay, I just want these 2, and I just want those 2. So you're pulling them out. And it's an array, so you've done this before with the square brackets. You've pulled pieces out of arrays and stuck them together to do other things. And the thing that's going to happen is, right here, is it's really going to want to drop that leading 0, because it's a number. And it says, well, it's a leading 0. Those are meaningless. And no, I need those. Because just because it's a leading 0 now, when I moosh it to something else, it's no longer a leading 0. And the fact that it's gone throws everything off. And cats will be sleeping with dogs, and it'll just not work. Now, one of the things that Apple tells us for data is there are 3 classes that they like. Now those of you who are new, you've looked at Swift and you said, well, Objective-C, that's for dinosaurs. Apples doesn't quite think that way in this place. All three of them are slightly different. There's NS data, NS mutable data, and data. Data is the Swift version. It is toll-free bridge to NS data and NS mutable data, which happen to be toll-free bridge to CF data. We're not going to talk about that. Here's one reason that you might want to switch on the fly. When I'm logging these statements out, Swift very helpfully tells me that my data object is 5 bytes long. Oh, thanks. I don't care that it's 5 bytes long. I really would like to see the contents. When I cast it to NS data, the default debug description for NS data is a string representation of the data. That's much more helpful to me. That's one example. There are other places where you should always look at all three just to see what's the difference in how they do implementation, especially with substrings, substring subdata, with some of the pulling things off the beginning, things off the end. Look at the three different classes. And then I talked a little bit about this radix thing. So you can see that if I give it this value, this hexadecimal value that the designer has given me, there's the decimal value, not helpful. However, if I flip it over to binary, maybe I want to do something with it, or maybe I want it to be printed out as hexadecimal. Right, so what? Here's an example that might make more sense to you. Oh, no, sorry, that's the next slide. Here's an example that should make no sense whatsoever. The other thing we can do is we can move digits back and forth. So this is kind of cool. You've seen these sometimes in code. You've got the 2 alligators this way or the 2 alligators that way. And it's basically saying either add binary zeros to the binary representation of this number or lop off digits. And so you're moving that number back and forth, either adding zeros or taking them off. And then just for completion's sake, so this is actually kind of a cool one if you want to impress your friends by writing some obfuscated code. When you need to divide by 2, you just shift by 1, it divides the number by 2. Because if you think about it, the binary number, lop that thing off, you divide by 2. And then they don't understand your code and you keep your job longer. The last one down here I'm just putting for completeness, because when you look at the first two, they always have this third one. Personally, I've yet to find a good use for it, and this will flip all the 1s to 0s and the 0s to 1 and tell you it's negative. So that's this tilde. It has nothing to do with my talk, it's just you're going to see it. Okay, now here's something that make more sense than what I'm just talking about. You've seen this before, I know we've all run into it. The designer hands you the hexadecimal representation of the color that they want. And you've explained to them 100 billion times that UI color wants the red, green, and blue as numbers between 0 and 1, and then an alpha. They don't care. This works for the red, it should work for us. The red is the first 2, BA. The green is the second 2, DA. And the blue is the last one, 5. And that will make the color that the designer has decided will get you or start up the funding it needs. So what I'm going to do is I take that hex value, and it is a 24-bit long number. So if I convert it to its binary, it's 24 bits long. I'm going to lop off 16 of the 24 to be left with 8. That's the red. That's what I'm doing. I'm lopping off, so I know it's 24 bits long, pull off 16, I've got 8 left. I know that's the red. And then I'm using this FF mask, and you'll see why on the next page that I have to do both. Then the green, that one's hard, that's in the middle. I can't just lop off these and then add a bunch of zeros, that won't work. So what I have to do is kind of lop off 8. So lop off the blue, now I've got the red and the green stuck together. And I'm using this mask. The mask, notice, is 2 digits long. If you were to lop off the green part of the hexadecimal value at the top, you just have BADA. That's 4 digits long. But with my mask, I'm able to say, only give me 2 digits. And that's the way I'm able to then pull out the green value. And then the blue value is pretty straightforward. I just mask the original one. Just say, give me those last 2 digits. That's what that mask is doing, that ampersand. You've written if statements, and you've probably, or maybe you haven't, maybe you don't care. I always wondered, why do you have to do 2 ampersands in an if statement? Well, you have to do 2 ampersands in the if statement because that's a Boolean comparison for AND. Because this came first. And this AND is taking the digits, and it's comparing them together. A 1 in the first and a 1 in the second gives me a 1 at the end. 0 and 0 give me 0. 1 and 0 will give me 0. And that's the way I'm able to then only have 1s and 0s that I care about come down. No 1 will come down unless my mask had the 1 in that spot. So then I can make this badass color. Again, here it is with the digits. Maybe this is easier for you to see. Is with the binary, you can see very clearly the red mask, that's the first 8. The green mask, that's the middle. The blue mask, that's the end. And by applying that to the binary representation of the color that I started with, I can pull out the pieces. Then the last thing you want to do, because you've been moving things back and forth, you've been making strings and numbers of strings and all sorts of crazy stuff, you can dip down way low down into C, below Swift, below C. This makes you also look really cool to your coworkers because they don't know what it is. This is string to long, long, string to long, and string to unsigned long, the first 3. And you give it the string that you want. You tell it what representation that string is supposed to have. So we say the first one, that's a 16-bit number. The second one's a binary number. The nil is if you wanted it to stop before it got to the end. So normally you choose nil, because I'm going to pass you the whole string as a number. But if I had a bunch of text and I wanted to stop at a certain place and not worry about the text afterwards, then I would put something in there and say that's the stop. Now, one of the nice things about this, you're probably familiar with the 4th one, which is where you say int some string, and you get an optional back. It either worked or it didn't. Sometimes you don't want that, because now you've got to unwrap the optional blah, blah, blah. These up here will give you the value, or they'll give you 0. But you don't get an optional. So depending on your code and whether you want optionals or don't want optionals at this point, here's a choice for you. Now down here, because floats are really not that easy to represent as binary, you don't get to do the conversion. You can give it a number, and it'll turn it into a float or a double. It will let me do hexadecimal for some reason, but not binary. Remember I showed you OX means hexadecimal, 0B means binary. This hexadecimal works, binary doesn't. It's probably my problem. But this is the other way. I'm converting all these things back and forth because the numbers aren't actually numbers. And then you get to the last little point, which is dealing with vendors. Vendors, as we saw, don't ever follow the GATT standards. Each vendor you deal with will be different. And this will sound xenophobic, but I don't mean it to sound xenophobic. I unfortunately only speak English. I only live in this country. And when I have to deal with a vendor not in this country, sometimes their customs and my customs make me nervous. So here's the website of one of the vendors I use. Wellcore is one of the biggest Bluetooth vendors there is. And this is their website for technical support. So I bought a case of sensors from them. I now need them because they're not using the GATT database. I need them to help me out here. This is their, oh, you're not going to be able to read it. Oh, it's going to be terrible. Anyway, technical support page so I can get it. And then if you can read this, oh, you can read it. This is the bottom of their technical support page. This is sort of the text that they've got on their page. And you're thinking to yourself, So I'm bringing this up to you because you're going to run into this. I ran into this over and over and over again with the different vendors I was using for these sensors. And they're just different. For some reason, this is important. And you can still deal with a company, you can still feel comfortable giving them your money, and that you're going to get valid things back. But this happened again and again and again during this project, as I was dealing with different vendors. Okay, so I have basically no time, but we're going to do it anyway. Can I have 30 extra seconds, please? If not, just walk out. This is the sensors that we've been using. Just wanted to show you one more time. If you're triggered by bad grammar, just look away. But this is the advertising payload that those little sensors in the back send to me. And this is the vendor's explanation of how I need to go through and parse that so that I can get all the data out that I want. So they let me know that there's the packet link. Okay, so here all we'll do is be the mirror and no. H. And of course I don't have a cursor anymore. It's invisible because that happens when you use Keynote. But I remember this because I'm old. Okay. So here's a playground that I'll be putting in the slides. This has also, if you want to play with it, this is a representation. But what we're having to do here, so this is pulled from Stack Overflow just because I'm trying to translate a string, and I'm sure that this is as good as anything, but I do reference it, not stealing. And here we go. And they say to me, okay, what are you doing? Okay, the first thing it says is, I'm going to give you your packet length. Okay, remember it's a string, and so once it's a string, I can come down and I can just kind of go through and I can say, fine, look at the document, parse that. Look at the document, parse that. Little interesting thing we found here is they said, well, this is going to be the hexadecimal representation of your sensor ID. Well, no. This is the hexadecimal representation of that ID. Remember, I had them read one to me because they're printed on them. It's just straight up got the decimal digits. Even though it says it's the hexadecimal, little things like that make you nuts. Then another little thing that threw us, and then I'll be done, which is, here's an example of my temperature data. So my temperature data is 1, 2, 3, 4 bytes. However, only, 3.5 of them are the temperature data. The first 2 are flags. So what happened to us was we didn't realize that was an issue, because normally those flags are 0. And so leading zeros get dropped off. We took the whole thing, we were getting good values. Those first 2 flags, the first one's telling you the sensor's got an error. The second one is telling you this is actually a negative number. And since it's Celsius and since it was in a refrigerated container, that happened. But if you didn't do it that way, we were all of a sudden, I got a panicked call from the client because the huge chiller that was holding millions of dollars of blueberries was reading at 300 degrees. so I fixed it. But so what you're able to do then is I can say, okay, I'm going to mask out the first bit because that's this. I'm going to mask out the second bit because that's that. Now here's my temperature. Now I can deal with it the way I would think so. And then I can convert it to Fahrenheit. All of them do Celsius. None of these chips do Fahrenheit. It's just the way of the world. And then the last thing there, you do the same thing with humidity. Making sure to save those leading zeros. So remember, when you're doing your project, try to do the GATT database if you can. Assume the vendors will not follow the GATT database. Think about battery life, signal strength. Data is a collection, might even be an array. Watch out for leading zeros. Thank you very much.